So in module 8, we have vSAN requirement configuration. They haven't specified anything regarding the lab in this module. So it is just on an overview. Mm, What they are bringing, anything new is coming in vSAN. vSAN now has a capability of ESA, which is enhanced storage. And earlier it was OSA, original storage. So now with the new one, you have a more focus towards the hardware selection, and then network connectivity you have to design because it's, and earlier you when you were using OSA, you have to have a storage policies properly configured. Capacity management has to be done. Esoteric configuration changes now need not to be a concern about this. We have to be more focused towards the networking and the hardware selection. Storage performance related to cluster size and the hardware, how performance is derived in vSAN ESA. So more earlier, how it used to be, more host in cluster. So let's take an example. We have 6, and if we from 6 to 12, we'll increase the IOPS by 2 times. So we have to increase the aggregate number of storage, so to have a better performance. But in new version, ESA AF2 and ESA AF8, we are not supposed to have a like increase the number of nodes, because it's under the hood we are using NVMe. So it is only the network which can cause a bottleneck. Otherwise, like, there could not be any major concerns. So recommendations: strive for the proportional balance of the resources, CPU, memory, networking, that avoids the obvious and substantial bottleneck. Earlier, how it used to be, we had server CPUs, server HPA. This was a bandwidth. This was a fabric bandwidth. But since we didn't have a NVMe, it was just a flash on the P server. This is what overall we can gain from the that particular memory. Now, since we have a NVMe, the bandwidth of fast memory is better. That's why we can process large chunk of data. So it is much more effective. It's a representation how bottleneck can be avoided with the NVMe and by using vSAN ESA. So the only way is in here is to increase the number of storage when we face the slowness. Effect of the upgrade of storage fabric when using a faster storage device. So we need to use the better network because our storage end is already fast. Recommendation: prioritize the right resources in the vSAN ready node and the network design. Example: native host and NIC speed should be greater than the storage device count, should be greater than the native switch speed, should be greater than CPU, should be greater than memory. One recommendation: do not use tri-mode controllers with the NVMe storage device in vSAN ESA. So a tri-mode is basically a RAID RAID controllers. Do not use RAID controller when you are using NVMe in vSAN ESA. So this is a power of disaggregation to the vSAN. So we have a capability to use vSAN storage controller. We used to have a hyperconverged infrastructure. So this is for VxRail, what we used to use. Now we have two capabilities: compute cluster, in which we doesn't have a storage node. It is like majorly used for the compute process. And in vServer SC, it's like majorly for the storage cluster. SC means storage cluster. So provided the shared storage for the vSAN cloud foundation using a vSAN storage cluster integrated in the deployment and management workflow, choose aggregate storage using vSAN HCI. Disaggregate storage use the vSAN storage cluster. Consistent management experience with the vSAN HCI cluster. VCF licensing includes the vSAN capacity entitlements. So basically, like in this module, they have highlighted that they have vSAN ESA, which is nothing more like NVMe. So it will give you a better performance. And that's all.